In this video, we'll talk about aromatic compounds and what that means for a molecule to be aromatic. We'll start with a more familiar molecule first, E135-hexatriene. We draw out this molecule. We have 6 carbons in a chain, and then double bonds on carbons 1, 3, and 5. And the E refers to the double bond in the center, where the higher priority groups are on opposite sides of the double bond. The way we've drawn that here is accurate for E135-hexatriene. So this looks similar to the dienes that we've talked about in previous videos, but we have 3 double bonds now. But each of the carbons that are in this molecule are sp2 hybridized. So we have 6 carbon atoms. All are sp2 hybridized. Which means each carbon has an unhybridized p orbital. So my question is this a molecule with conjugation? Well, we can add in the p orbitals to each carbon atom. We said each one is sp2 hybridized. That means we have p orbitals all in the chain for all 6 carbon atoms. And so those pi electrons can resonate across the whole molecule. Those p orbitals overlap. And so we will say, yes, it is a conjugated molecule where all of the p orbitals are overlapping. And we can draw in that bonding molecular orbital. The lowest energy molecular orbital has all p orbitals overlapping across the entire molecule. So all of the electrons that are in pi bonds, there are 6 electrons in pi bonds, they can resonate across the full molecule. That's very stabilizing for a molecule, which we've talked about in previous videos. But this molecule is not aromatic. Aromatic molecules are similar, can be similar. And so let's actually think about 1, 3, 5 cyclohexatriene. And if we draw up this molecule, we have 6 carbons in a ring. We have double bonds at carbon 1. We'll say this is carbon 1. At carbon 3 and at carbon 5. You might recognize this molecule. This molecule is named benzene. And we have a similar bonding pattern where every other bond is a double bond, just like 135-hexatriene, the linear molecule. So we can also say that this molecule is conjugated. And if we compare the linear molecule above with benzene below, you might imagine that we take the 2 ends of the linear molecule. So if we have the linear molecule, then we kind of bring them together. And so now those p orbitals that are overlapping across the linear orbital, the linear molecule, are now overlapping across the entire cyclic molecule. So benzene is a conjugated cyclic molecule. Each carbon again is sp2 hybridized. That means that the full molecule is planar. And this is an example of an aromatic compound. I have an image over here that kind of helps us visualize the p orbitals in benzene. This molecule, the benzene molecule, is drawn kind of flat. You can't really see the back carbons, but this is a 6-membered ring. Each carbon atom has an unhybridized p orbital. And so you can see if we were to draw the molecular orbitals, so here's the molecular orbital, this side is atomic orbitals. The p orbitals overlap across the whole top of the ring, or that one side of the ring, for the blue molecular orbital, and on the other side for the green. So this is something that occurs in all aromatic compounds. We will talk in the next video about the criteria to determine if a molecule is aromatic or not, but I do want to show you this note here. You don't necessarily need to write this down, but the term aromatic was originally used to describe these compounds, these aromatic compounds, because many of them are fragrant. So I have 2 examples here. You can certainly find more. I encourage you to look up if you have a candle or lotion or perfume that you like, to kind of look up the scents in the molecule and see if they are aromatic compounds. So one example here is vanillin, which is the scent of vanilla. You can see it has that similar structure in the center here, where it's a cyclic arrangement of carbons that each carbon has an unhybridized p orbital. Another example is methyl salicylate, which is the wintergreen scent. Again, it has that kind of benzene-like structure here with some substituents on the ring.